All right, and welcome to this new video talking about our next steps in multiplication. Today we're going to be looking at multiplication as base 10. If you recall, last time we talked, we were kind of thinking about how to use this base 10 as a model. So we're going to go past the modeling part and really start to look at the patterns that we can find when we multiply by base 10. So just a quick review. If we had something, let's say 3 times 30, right? So what we were showing is we were building this base 10 model, or maybe I was showing 10, 20, 30, 1, 2, 3, and then I was thinking about this array, and I was saying, all right, well, 1 times 10, right? This 1 times this 10 is 10, 1 times 10 is 10, 1 times 10 is 10. So I guess me 30. Same thing here, 30. Same thing here, 30. So when I add that up, I get 90. So this is where we're using the modeling to look at that. And if you remember as well, and again, I'm just reviewing what we talked about in the last video, 3 times 3 was 9. And the discussion we started to pull out was, oh, well, I got 10 times greater here than here. Therefore, my answer is 10 times greater. And then we were like proving that through a model, right? Okay, so today we're going to just think about like how do we show this work without the base 10 model, but more just an understanding of what base 10 means. And remember, base 10 is just the way we count with our numbers. It's the whole system. 10 of one unit makes one of another. 10 ones makes a 10. 10 tens makes 100. 10 100s makes 1,000. Like that is what base 10 is all about. So let's kind of dig into this right away and think about what is it we're starting to notice with the patterns. And I'm going to put out a series of questions where you can see I'm going to get 10 times greater every time. Right? There we go. If I'm at 3 and I become 30, I got 10 times greater. If I'm at 30 and I got to 300, I got 10 times greater. So this is the idea again of base 10, that those place values are 10 times greater than the others. So let's look at this as a multiplication standpoint. If we were to model these, which we won't, that would support our work. So we want to think about that. Maybe we'll model a couple at the end just to kind of see what this means. So 5 times 3, right? 5, 10, 15. Okay. Now, let's think about this. If 3 just got 10 times greater, then my answer of 15 is going to get 10 times greater, which is literally 150. This idea that we can see that is really just a 0, right? All those numbers are moving over one place value. So now I move the 1 and the 5 into the hundreds and the tens. Therefore, I need to fill the ones place with a 0 as a placeholder, which gets me 150. Okay, so let's think about that again. Here, 5 times 3 is 15. And we could look at it either way. If we look at it from here to here, we got 10 times greater. So it was already 150. And then we just need one more 0. Or if you look at it from here to the 1, we got 100 times greater. And again, you can see my answer from 15 to 1,500. That's 100 times greater. 100 has 2 zeros in it. So there's my answer. Okay, so again, and we'll clean this up as we go. This is just like, you're looking for the pattern now. We'll kind of, I'll define it better later, don't worry. So 5 times 3 is 15. This is, if we go back to looking at 5 times 3 is 15, this is 1,000 times greater, and 1,000 has 3 zeros. So that would mean I would need that. And there we go, right? So this is kind of what we're seeing here. Oh yeah, all right. It's like all about base 10. It's all about place value. Base 10. So let's define that a little more. And there are steps. You know I like steps, so there'll be steps. So let's do this. Let's do 3 times 7. Let's do 3 times 70. Let's do 3 times 700. Let's do 30 times 70. Tricky. And let's kind of see what happens here. Okay, so if we think, and I'm going to break this into the steps, right? The first thing we really did here is we're going to multiply what I like to call the non-zeros. And those are the numbers that aren't zero. So in this case, 3 times 7, well, that's 21. Cool, done. Well, here, if I move on to the next one, I'm gonna do that same step. 3 times 7. Notice I'm underlining them. Like, do that. It's gonna be so helpful. 21. But now we have to realize that this next step, we have to think about how many times greater it is or how many zeros there are, right? This is 10 times greater than before, so it has 1 0. So what we do is we just really count our zeros. Count the zeros. So I see here I have 1 0 right here. So now all I gotta do is think about, oh, well, that's the new placeholder. So we put that 0 as a placeholder. So I ran out of space, PH, placeholder. So that 0 just goes here, 210. So we can just follow this rhythm over and over again. 3 times 7 is 21. We got 1, 2 zeros. So 1, 2 place values, 2,100. Same row here. 3 times 7 is 21. 1 0 2 0. 1 0 2 0. Oh, look at that. It's the same answer. Cool. So really, if we think about this process, this is how we can just use base 10. And this is what we were noticing yesterday in the way that we were multiplying those base 10 models, the way that we were showing this in arrays, is that things were getting 10 times greater or 100 times greater, so on and so forth. So multiply your non-zeros, count the zeros, put that 0 as placeholder. Put those zeros, put zeros as placeholders. Now that says zeros. Oh boy, I just made a mess of this. All right, there you go. Put zeros as placeholders because we never know how many there are. All right, let's do some more. Let's throw out a couple. What if we have like 80 times 3? Let's do 700 times 90. Let's do 600 times 30. I'll stop there. You know, this is where I always like to invite you to pause the video and solve these yourself and then come back and check and see. So pause. And now you're back. Wow, nice job. I don't know, did you pause? Maybe you didn't, who knows? So let's do our steps and solve this, right? Step 1, we're gonna underline our non-zeros. So 8 times 3, that's gonna get me 24. Now again, remember, like if you're not sure of those math facts, like if you're not sure of 8 times 3, build that array and just help yourself get it, right? 8 times 3 is 8 groups of 3 or 3 groups of 8. So you could do like 1, 2, 3, 4, 5, 6, 7, 8. And I would need 3 of those. And you'll start to see really you won't even have to draw the arrays anymore as you realize the system is that I actually, like I said, it's 3 groups of, or here in this case, let's do it, this is easier, 8 groups of 3. So I could just skip count by 3s. So 3, 6, 9, 12, 15, 18, 21, 24, right? So again, skip counting, what a great friend. All right, so underline the non-zeros, 8 times 3 is 24. Count my zeros, I see 1. So I place that placeholder at the end, 240. Okay, underline the non-zeros. So 7 times 9, that's 63. I'm gonna count my zeros. Remember, here's the part that gets tricky, is count them in both numbers. So there's 1, 2, 3 total, right? I'm gonna count all the zeros I see, which means I need 1, 2, 3. And 63,000 is the answer to 700 times 90. Pretty impressive. All right, underline the non-zeros. Multiply them 3 times, or 6 times 3 is 18. Count my zeros. 1, 2, 3. 1, 2, 3 as the placeholders. Your answer is 18,000. So this is that base 10 multiplication. It's pretty fun. It's pretty tricky. Once you figure out the rhythm, I think you're gonna enjoy it. Let's play around with another one because this is often what will happen. They're like, okay, cool, you get it. So what if I had like 30 times what, right? So now we gotta figure out what we're multiplying by. So let's see, 30 times what equals, I don't know, 18,000. Okay. So now we got to think, okay, how do we balance this out? So the first thing, same process really, is think about just this. So think about in your head, 3 times what equals 18? Well, the cool thing about this is I could skip count by 3s until I get to 18 to get my answer, right? 3, 6, 9, 12, 15, 18. So there's my answer. But how many times did I have to count? 1, 2, 3, 4, 5, 6. So 3 times 6 is 18. So we know this will be a 6. Okay. Right? Because 3 times 6 is 18. And then we could just do kind of a process of elimination in a sense. Here's 1 0, which means that would be this one we drew. And then we would need what looks like 2 more zeros. So I could put them in there, and it should be 600. Now, I say should be because I really want to make sure you always go back and double check, because you actually know how to do that, right? Don't play that guessing game. Don't guess, no. So 3 times 8 is 18. 1, 2, 3, 1, 2, 3. Yep, that checks out, right? So 18,000. So the answer was 600. Okay, so let's do another one like that, because those ones definitely I think are where people get confused. So what if we had 40 times what is equal to, actually, no, not that it matters, but I'm going to do it anyway. Let's just flip it. So, sorry, let's say what times 40, that's all, equals 2,000. All right, now this is where it can get even trickier, because now we're kind of thinking, oh, if I think about my non-zeros, I have this something times 4 equals 2. That doesn't really make sense to me. So what I'm going to do is I'm going to think about this as a 20. So now I've used these 2 digits, right? They've been accounted for, if you will. So we'll clean that up. So now I could say, oh, well, what times 4 equals 20? Well, again, if I'm not sure, I can skip count out by the 4s. So I could go 4, 8, 12, 16, 20. And that was 1, 2, 3, 4, 5. Okay, so 5 times 4 is 20. So, but remember, it's 20. So I already used this 0. This 0 and this 0 would cancel. So it looks like I would only need 1 more 0. That there. And then we just test the theory. That's the greatest thing. Like, this is what I keep trying to have us all think about, that math is an exploration. It's not about being right the first time. It's about exploring and trying and saying, hey, does this work? No. Cool. Well, let's try something else. That's what it's really about. And as soon as we really start to understand and recognize that, I think we'll have a lot less anxiety when it comes to math. So 50 times 40. So I'm just testing my answer, right? And I'm going to see, do I get 2,000? And if I do, this works. So underline the non-zeros. 5 times 4 is 20. Count 1, 2, 1, 2. And there you have it. Checks out. Okay. So that's where we are with this base 10 multiplication in terms of just like having a fun algorithm to do it, right? Underline the non-zeros, count your zeros, put them as placeholders, boom, you're done. So again, underline your non-zeros, count your zeros, boom, you're done. So give it a go, ask questions as always, and as always, thank you for being here and your hard work, and we'll see you next time.